Good afternoon, guys. Welcome to our Ruby programming language lessons. In this lesson, we're going with our object-oriented programming details. Especially, we focus on object instances, inheritance, subclasses, superclasses, structures. So, without wasting any time, I would like to start up our tutorial, our lessons. In this next lesson, I here define a vehicle class, and within this class I define a method such as make underscore sound, and it's gonna give bool on the screen, and this is the end block for class vehicle. And here I create another class which is a member of this vehicle class. So it is a subclass. Car is a subclass of this vehicle superclass, and there is nothing done in within car class. So I here define create an object of car class, and I use make sound method together with this object. Okay, here would like to get it printed so we can see. So bool is printed on the screen. Just a quick view. This is the method. Okay, within the method this is performed, and car is created. Okay, this is the method. I here make a quick example, a simple example. Here I create a class A, and this is my variable, class variable. I here define a show method. It's gonna put num, the value of num variable, and it ends. It's gonna end. Okay. I here define another B class, class B, which is a subclass of A. So I here define an initialize method. Num will be initialized as 2, and this is the end. And after the end block of class, I here create an object, an instance of B class. Okay, and I use show method. So this part will be running. Okay, just to make sure that. Okay, why it didn't print out number 8? Because number 8 is within the scope of class A. So we're talking about B subclass. So I especially choose this one by this notation, and I use show method which is regarded to our superclass A. Okay, we go on with our examples with classes and objects. I here create an animal class, and I here define an initialize method that's gonna take name and color variables, arguments, sorry, and this is our class variables. Look at this notation. Okay, and this is the end. I here define a speak method. It's gonna print out hi text on the screen, and here after end blocks and keywords, I here define another dog class, which is a member of animal. This notation means dog class is a member of super animal class. Okay, and there is nothing to be done within this class, and there is another class cat, which is a member of animal superclass, and our attribute accessor is age with a semicolon. Focus on this, okay. And here I define another method here, speak method. It's gonna put meow text on the screen regarding cat's voice, and end. This block simply ends. So when we created an instance of cat class with two parameters, two arguments, Lucy and White, and I use a method here, and my method just accepts 2 as an age, and I here use another method, speak. So we can expect two of them will be printed out on the screen. Okay. Just this is printed. Okay, sorry, I made a mistake because when we call speak method, okay, this is the method, only this line will be performed, because this is just initialization, does nothing in fact. Okay, meow is printed on the screen. Let's go with another class, a simple class in fact, class A, and I define a foo variable, so foo method. It's gonna print out 1 on the screen, and I here create another B class, a member of A, another foo method, and it's gonna print out 2 on the screen, and here I create an object, B object with new keyword, and this object accepts foo method. Okay, this is gonna print out 2 will be printed out. Okay, as you expected. I think it's understandable, and it's easy to understand, I think, yeah. I here create an animal class without doing anything. I here, and this animal class has got mammals, and dog class, subclass, is a member of mammal. So this is an example, a specific example. Subclasses can be nested. There is a nested structure in fact. Just I can show this. Okay. Okay. We are talking about a superclass here. Animal is a superclass. A built-in method I'm going to talk about. Within the frame of animal class, I define speak method. It's gonna print out hi on the screen, and here I create a subclass of animal class, and I here define a speak method, and I here call super, and it's gonna print out meow, and this is the end block. So when I create an instance of cat class, I would like to use a speak method together with this, and let's make it run and see the result, how it's gonna be. Meow. Okay, just this super keyword reminds that this block will be recalled, will be performed. Okay. Here I give another example with superclass. My class animal is created here. I use initialization method with 1 argument. This is a class variable, and I here create a subclass of animal. I here initialize with 2 parameters, name and age, and I here would like to convert it to string, and this is the structure. Just it seemed to me the same with some of previous examples. Anyway, this repetition and repetition becomes expert. By means of repetition, anyone becomes expert, becomes experienced. Okay, this structure is name is blah blah years old, and we're talking about cats and very small ages. Bob and tree will be accepted as arguments of this class instance, and we would like to get it printed in content. Actually, it is already converted to string, so there will be a formatted structure. Bob is 3 years old. Bob is a cat. Here, I'd like to give an example of overloading. Here, I define a shape class with attribute accessors, height and width. This is the initialization method. This is the variables self.age. This stands for this one. Okay, this also this one. When you change, you have to repeat the change similarly. And here define another method. This format is valid. Of course, it seems weird, but it works fine. Shape dot new open parenthesis self.age plus other dot age, okay, comma self dot w plus other dot w. So our class is end here, added here. So I here would like to create 2 points. Actually, this is related to vectors. In fact, this is starting point. This is the next point. As a first object, I use these parameters 7 and 4. For the second object 9 and 18, so it's gonna sum, it's gonna add, and here I'd like to get it printed the first object and the second object for height and for width, and let's make it run. Okay, just a little bit upward. Okay. 7 plus 9 equals to 16 as width, and 4 plus 18 becomes 22 as height. Let's go with another example. Here go on with our box class. Attribute accessor has got 2 parameters such as width and height. This is the initialize method. I create instances. I create instances, and I define asterisk open parenthesis object, and by means of this structure, just I can print out, I can show this knowledge, this information. Just okay. As you see, there is no command to print out what it is done within this class structure. Just I gave this as an example. Okay, with the help of our next program, next snippet, we can go on with access modifiers. I here define a class, create a class person. This is the parameter. Parameter h is a class variable, in fact. So this is the method, show method. I would like to get it printed, this structure, this string, blah 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 years equals blah blah days lived years. So I'd like to find out how many days are there in such and such a year. It's easy to calculate it. I here multiply the class variable with 365 so as to get days lived or days, and this is the end block. Just one quick repetition. Initialize method. This is the h variable, and this is the message to be printed out on the screen. And in the private mode, I calculate the days, and here outside of the class person, I create an instance of person by using 59. That means my age 59 corresponds to how many days? God bless me. And here I use this instance with show method, and when I run this file, this snippet, I'd like to get 59 years equals to 21,535 days. Oh, I here made a mistake. Days. Okay. Okay. 59 years equals to 21,535 days. Okay, let's go with our next example. I here would like to give an example for protected variables. Our class product, our attribute accessor includes two parameters, two arguments such as name and num. This is the initialization method. Actually, I assign name and num as class variables. I here define such structure equal to others. This is the method. In fact, it's gonna inquire whether this equals to other, and self ID equals to other ID, and this is the private part. Length and num will be printed. Okay, just instead of speaking, I'd like to show the result. Okay, just here I create an object with this parameter, right? Okay, I created another object with this because it'll give error, because why? I would like to get it printed P1 equals to P2. Actually, this is not true, because the value, the output for this and the output for this one is different from each other. So it's gonna give error just as it described here. It gives the details. Okay. This example actually show us that within the frame of class and methods, we can do anything such as inquiry, such as comparisons, etc. I here define a class product with attribute accessors name and num. I initialize it by using class variables, and I here make an inquiry so as to find out whether it is equals to the other, and I make this inquiry here, and okay. Okay, actually, as a result of this inquiry, this comparison, it's gonna give false, in fact. So false will be printed. What is different from this one? PC 5, laptop 3. Okay. Anyway, I will describe it later. Okay, you guys, this is the end of our lesson for today. Thanks for watching me, and in our next lesson we go on with classes and object instances and inheritance. Bye bye. Thanks for your watching me. Have a nice day. Bye bye.